Hi, this is Nathan Helms going over my weather data from the third week and comparing it with data collected from the National Weather Service. Once again, I like to take my data at 1:50 in the afternoon, and data collected from last week on the 27th, I had a current observation temperature of around negative 36.4 degrees, which is quite close with what was taken at the weather station. They had a negative 38. Their pressure was 1,031 millibars for that day, opposed to my 1,028. So once again, there wasn't too much variation. For the next day, on the 28th, I had a observation temperature of negative 22.2. The weather service had one of negative 36 degrees, so I was considerably warmer than their weather station. And they had a barometric pressure of 1032, while I had one of 1020. So there was also quite a difference in the barometric pressure. On the 29th, I was at negative zero point 0.2 degrees and 1008 millibars pressure, and they had negative 9 degrees and 1013 millibars. So once again, their barometric pressure was higher and their temperature was lower than mine. On the 30th, I had 6.1 degrees, and the National Weather Service reported 4 degrees. They reported 1009 millibars, and I had 1013. So I was finally higher than them on that one. And on the last day, the 31st, I had 9.25 degrees, and the National Weather Service had 10. And our pressures were 1 millibar off. I had 1015, and they had 1014. Looking at the graph for temperature, their data really lined up with my minimums and only seemed to come into my current temperature here at the beginning and near the end where the minimum temperature strayed away. On the pressures, they both seem to follow the same trend where theirs is downsloping, mine is as well, uh, until we get down to here. Theirs continues to go down, but mine starts to build, which kind of seems to mirror this whole thing if I could transpose that over. Then the humidity, I had no way of taking humidity readings, so this is just what the National Weather Service got. Then going over to here is the newsroom TV weather maps. So you can see there's a high pressure system over Fairbanks and over Russia across the Bering Strait, with low pressure systems pushing cold air down to the Gulf of Alaska. The National Weather Service's report for barometric pressure on the 27th was 1031 in the Fairbanks area. So I think that really well lines up with this high pressure system reading 1034. Going to the next day, there is the high pressure system is continuing over Fairbanks and is joined up with the high pressure system over the Russian over in Russia and over the Bering Strait. This low pressure system is still down along the panhandle of Alaska, pushing colder air down into the Gulf. This high pressure system here at 1042, the National Weather Service only recorded a 1032, but that is, I still think, within a tolerable range. Fairbanks is a bit lower down here under some contour lines once we get into lower pressures, so that could easily explain the difference. And on all of these, there is a cloud cover. I forgot to mention that on the 27th. Pretty solidly cloudy over Fairbanks on the 27th and 28th. Finally, on the 29th, cloud cover starts to break. There was some snow along here, as you can see. The high pressure system has moved over into Canada now, and the low pressure system has moved from the Panhandle to the Gulf. This low pressure system, at a value of 999 millibars, is fairly close to 1,000, which I think is quite high. But once again, I just started doing this, so I don't know what's normal yet. Going to the next day, the 30th, you see that high pressure system is still over there right along the border to Canada, with another higher pressure system coming in over from Canada. This low pressure system looks like it's moved further south, and these low pressure systems were just came in uh, this day and are blowing cold air towards the interior, while cold air is also getting blown down into the Gulf, actually going into the Gulf from both directions. On this day, I had a recording of 1009 millibars for Fairbanks, so this is where the barometric pressure really started dropping compared to where it was at the beginning of 1031. And this makes sense because that high pressure system is quite a ways away from where where it was at the beginning. Also on this day, if I remember correctly, was the day we got snow, which we can see is illustrated by this map. There's snow dropping in the interior and down along the southern part of Alaska. Here on the 31st, this high pressure system still maintaining its position, maybe a little bit further into Canada. The high pressure system behind it has disappeared, and one's now appeared in the Bering Strait, a little bit south to it, and a low pressure system is above it. There is a low pressure system out near the end of the Aleutian chain, and this low pressure system down here that's kind of cut off down to the south of Alaska, with two more low pressure systems, so five low pressure systems here on the map, and these are down at the southern part of Alaska, one closer to the Panhandle and one closer to the Aleutian chain. On this day, it was recorded that the barometric pressure was 1014, which matches spot on. If we say Fairbanks is right about here, it's one contour line away from 1020, so pretty close to being 4 millibars away. I didn't have any data for Friday, February 1st. I started recording on that previous week Sunday, so those were my 5 days. So I wasn't able to have much to go off of here, but you can see a high pressure system up near the Arctic Circle above the Bering Strait. Another high pressure system here further into Canada, with a low pressure system nearby also further into Canada, and this high pressure system closer down to Washington. And then there are these two low pressure systems out in the ocean, one in the Gulf of Alaska and one over near the end of the Aleutian chain. I was provided these four maps of the weather on February 1st. I'm supposed to use the TV weather map along with the visible light, infrared, and water vapor maps, and use those to make some more accurate assumptions about what the weather did. So looking here, we have the high pressure zones, low pressure zones, and a high over here in Canada. I just covered this in the previous slide. So going over to the visible light graph, since there is no way that light could get up to up above here at this time. We don't have much data about that, and that's why there's a kind of blackness up there, and which was kindly marked by the TA. So here we can see there's a really high cloud bank here, thick high cloud bank. It's a very bright white, so you can tell that it is very thick and probably up in the air. It's very solid. There's also this cloud bank that seems to be going here. Both of these match up with the TV weather map. You can see this can kind of be brought into that, and we just only get to see this part of it, and this line follows along the edge of this low pressure system really nicely. Going down to the infrared, you can see that out of all of these clouds that are kind of everywhere, these two major fronts are the ones that really get picked up. Once again, you have that strong cluster and the edge of that low pressure system down to the south of Alaska. Then over here, the water vapor, those are clouds that are wet clouds. They have rainwater or some things along those lines that are giving them moisture content. And so those could be expected since they are moving north towards Alaska, could possibly bring with them snow further on in this week. And I thank you for listening to my web forecast, and have one out next week.